Good morning, dear students. Now, in the last video we have seen about the quantitative analysis of halogen and sulfur. Today we will see the quantitative analysis of phosphorus and oxygen, and it will be our last topic of the chapter, and then half of the exercise is remaining, half we have already solved. Then we will start with the new chapter, right? So now let us see the analysis of phosphorus. Here also a non-mass of an organic compound is heated with fuming nitric acid. Compound containing phosphorus is heated with HNO3, and the phosphorus present in the compound here, it also oxidizes to phosphoric acid H3PO4. H3PO4 is the formula of phosphoric acid. So phosphorus is present in the compound P. It is then reacted with HNO3 and converts to H3PO4. Phosphoric acid is then precipitated as ammonium phosphomolybdate. Now this phosphoric acid H3PO4 is now precipitated. That means PPT is formed. It is formed how? It is formed in the form of ammonium NH4 thrice phospho-PO4 molybdate MoO3. Ammonium phosphomolybdate. Ammonium phosphomolybdate NH4 thrice PO4 12 times molybdate, that is molybdenum trioxide. This is obtained by adding ammonia NH3 and ammonium molybdate, that is NH4 thrice MoO3 to phosphoric acid. So this two is added, ammonia as well as ammonium molybdate. These two are added to the phosphoric acid to get ammonium phosphate molybdate, ammonium phosphomolybdate. And this phosphorus can also be estimated by one alternative method, and that is phosphoric acid may be precipitated as magnesium ammonia phosphate. Magnesium ammonium phosphate. So instead of molybdenum, it is also calculated or precipitated by magnesia ammonium phosphate, and it is obtained by adding mixture which on ignition yields Mg2P2O7, that is magnesium pyrophosphate. So here see organic compound when reacts with fuming nitric acid and heated, it converts to H3PO4, right? And with it the water medium nitro compound is also available. Now this H3PO4, that is phosphoric acid obtained, is reacted with ammonia NH3 and ammonium molybdate NH4MO. And the product which is obtained is ammonium phosphomolybdate. This is the product, ammonium phosphomolybdate. The alternate is here, organic compound when reacts with fuming nitric acid and heated, phosphoric acid is formed, H3PO4 along with nitrogen dioxide and water is also formed. And this H3PO4 which is formed is now reacted with ammonium chloride NH4Cl and magnesium chloride. Both chlorine, that is ammonium chloride, and magnesium chloride, both are reacted with H3PO4, and thus magnesium ammonium phosphate is produced. This magnesium ammonium phosphate is ignited, and on ignition it gives Mg2P2O7 magnesium pyrophosphate. That is Mg2P2O7, and ammonia and water is liberated out, right? So both the way we can calculate, either we can calculate phosphorus from ammonium phosphomolybdate, or we can calculate phosphorus by magnesium pyrophosphate. So in calculation, whatever the organic compound is taken, that is m gram. Ammonium phosphomolybdate is m1 gram. Total molar mass of NH4 thrice PO4 12 MoO3 is 1877 gram per mole. And if we are supposed to calculate, so molar mass is 1877 gram, and the percentage to find out is 31, that is the atomic mass of phosphorus multiplied by, so here only 131 only, because in whole ammonium phosphomolybdate we have only one phosphorus P. So 31 into M1 into 100 upon 1877 multiplied by M. In the same way, if the phosphorus is calculated or estimated by magnesium, then it is Mg2P2O7. So here phosphorus present is in 2. So it will be 31 into 2, that is 62, rest of the things. And now see here it is this ammonium phosphomolybdate, and here it is ammonium Mg2P2O7, right? So it is magnesium pyrophosphate, and here it contains 2 phosphorus, so 2 into 31 will be 62, and 1 into 100 upon. As this is a smaller unit, Mg2P2O7, right? So molecular mass here is to be taken as 2 into M. Now let us see here. So you see the difference. 1877, it is the molecular mass of ammonium phosphomolybdate, and 222 is molecular mass of magnesium pyrophosphate. 0.29 gram of an organic compound containing phosphorus gave 0.887 gram of magnesium pyrophosphate by the usual analysis. Calculate the percentage of phosphorus in the compound. So mass of the organic compound is M, 0.29. M1 is production of Mg2P2O7, that is 0.887. And percentage of phosphorus, now we are taking Mg2P2O7, then the molecular mass is 222. If we consider the ammonium phosphate molybdate, then 1877 is the molecular mass. So putting the value 62 into 100 upon 222 into M. So here 62 gram multiplied by M1, that is 0.887. And you see the calculation, and here find out the percentage. 62 into 0.887 into 100 upon 222 into 0.29. This gram will be cancelled, this mole will be cancelled, right? And so answer will remain in the percentage. So now let us see quantitative analysis of oxygen. The percentage of oxygen in an organic compound is usually found by difference between the total percentage composition on the basis of 100 and the sum of the percentages of all other elements. Oxygen can also be estimated directly as a definite mass of an organic compound is decomposed on heating in a stream of nitrogen gas. The mixture of gaseous products containing oxygen is passed over red hot coke when all the oxygen is converted to carbon monoxide. So what is here? The mixture of gaseous products, whatever the gaseous products are there and which contains oxygen, but not all other gaseous product where oxygen is not there. Gaseous product which contains oxygen, it is passed. That means that gas is allowed to pass on a red hot coke when all the oxygen is converted to carbon monoxide. And then this mixture is passed through warm iodine pentoxide I2O5 when carbon monoxide is oxidized to carbon dioxide. So more oxygen is added and by producing iodine. So organic compound on heating gives oxygen, that is O2, and other gaseous products. Now see here, 2 carbon plus O2 will give 2CO and I2O5 plus 5CO, and it is I2 plus CO2. And to balance this 2, right, it is multiplied by 5 and multiplied by 2. So they both can be balanced. And thus 88 gram of carbon dioxide is obtained if 32 gram of oxygen is liberated. So how the comparison is done? That if 32 gram of oxygen is liberated, that means O2 gas is liberated, then 88 gram of carbon dioxide is formed. Now let us see here calculation. Mass of organic compound m gram. Mass of produced carbon dioxide is m1 gram. So m1 gram carbon dioxide is obtained from 32 into m1 gram upon 44 gram, that is carbon dioxide, and from that the percentage of oxygen is equal to oxygen, that is 2. So 16 to the 32 into m1. What is m1 here? Mass of produced CO2 into 100 upon molecular mass of carbon dioxide, and that is 44 into m, that is whatever the compound we have taken. And thus the percentage of oxygen can be derived from the amount of the iodine produced also. So calculating all compounds mass and then subtracting it from 100 will give the percentage of oxygen. And at present, and to calculate oxygen in one of the numerical we have already solved. But now see here, at present, that in this generation, in this scenario, the estimations of elements is kept secret, and so it is considered in an organic compound as carried out by using micro quantities of substance and then automatic techniques. The elements carbon, hydrogen and nitrogen present in a compound are determined by an apparatus known as CHN. CHN is carbon, hydrogen, nitrogen analyzer. This is the electronic device. The analyzer requires only very small amount. So at present the techniques are so fast, so automatic that even 1 to 3 grams of substance when taken, and in a fraction of time it will display all the rules on the screen. And then this is how the oxygen is estimated, right? And this is the way how to estimate the different elements or different function group present in the organic compound. With this, all our theories we have finished. Even half of the exercise also we have solved. Now remaining questions what are left, and wherever the experiments are need to be written, so that you can start writing by yourself. For writing of experiment and all, solution is not necessary. And rest of the questions, I'll see what are in need of the solution that will be solving, right? And then we'll start with new chapter. So please try to prepare whatever is already taught. Thank you.